All right, guys, another topic you all have on Study Island for week 1 of NTI is on rational approximations. What this is basically asking you to do is to take a number that is irrational, that does not have a way of being written as a fraction, and it's asking you to make a rational approximation. So when we take a number that is irrational and we round it, we are creating this approximation that is a rational number, okay? So we're going to start back. I'm going to look back at our number line that we drew in one of our other videos. So we have our x values are going to go up here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down here on the other side of this number line, I'm going to square all of these numbers. So we're going to do our squares again, our perfect squares. So 1 squared we know is 1. 2 squared we know is 4. Drop my marker. Sorry. 3 squared we know is 9. 4 squared is 16. 5 times 5 is 25. Okay. 6 times 6, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared puts us at 100. Okay. So if I were to ask you the square root of any of these numbers, we have these nice perfect whole numbers up here. The square root of 49 is 7. The square root of 64 is 8. These are nice, perfect whole numbers. They're beautiful. Okay? But what we know sometimes in math is they don't always ask us those nice, perfect numbers. So one of the things we talked about before we left was that if I asked you to find me the square root of a number like 10, we're going to estimate it. So if I'm looking down here, I know 10 falls in between 9 and 16. Okay? So 10 is between 9 and 16. So the square root of 10 is going to be between the square root of 9, which is 3, and the square root of 16, which is 4. Now, the piece that we did next is I know now my answer is in between the number 3 and 4. So now we have to decide what it's closest to. So if I look at the number 10, is 10 closer to 9 or is it closer to 16? It's going to be closer to 9. So what that means is that my answer is going to be closer to 3 than it is to 4. So then what we can do is we can start kind of guessing, essentially, an estimated guess, a close guess. So I could say maybe 3.2. Now, if I want to check that, what I can do is I can take 3.2 and say, what happens when I square 3.2? 2 times 2 is 4. 2 times 3 is 6. 0. 3 times 2 is 6. 3 times 3 is 9. And what we're going to find, I got 2 decimal places, and you can by all means use a calculator for that part, is that I'm a little bit over 10. So this estimate is just a little bit high. So what happens when we go down to 3.1? Let's try that. 1 times 1 is 1. 1 times 3 we know is 3. Got a 0 again. 3 times 1 is 3. 3 times 3 is 9. So I have 2 decimal places. 9 with 2 decimal places. Okay. That number is too low. So what that now tells me is that I've gotten even more specific. So more specifically, the square root of 10 is going to be between 3.1 and 3.2. Okay. Now, it was about 24 hundredths too big right here. And it was about 39 hundredths too small. So I'm pretty close to being right in the middle of that. Okay. So what we could do is we could say, okay, what if I tried 3.15? And I go right in the middle of those two. All right. Now this is going to get to a point where it gets a little annoying to do without a calculator. Okay. But it can be done. 5 times 5, 25. 5 times 1 is 5, plus 2 is 7. 5 times 3 gives us 15. I got a 0. 1 times 5 is 5. 1 times 1 is 1. We're done with that. 1 times 3 is 3. Now I have 2 zeros. 3 times 1 is 15. Carry the 1. 3 times 1 is 3. Plus 1 is 4. 3 times 3 gives us 9. And then I'm going to add those up. So we got 5, we have a 12, 10, we have another 12, 4, 5, 6, 7, 8, 9. So now if I look at this answer, and I have 4 decimal places, 1, 2, 3, 4. So I moved 4, 1, 2, 3, 4. Now if I look at this number, I'm now at 9.9225. Guys, go. Sorry, my dogs are in my office. Okay. I'm now at a number that's really, really close to 10. So I now could say my answer is about 3.15. And notice I didn't use an equal sign because we're not going to have exact answers because we are approximating. We are rounding. So you are not going to have exact answers. Okay? All right, let's look at another one. Let's get this all wiped off. All right. Another thing it might ask you to do. It might ask you to talk about a statement that would compare two numbers. For example, the square root of 91 and the square root of 92. And it's going to ask you to compare those two numbers. Okay. What I know is that if I were to take this number and square it, the square root of 91 squared. Remember square roots, and when we square that, those two cancel out. So that's just 91. I also know that the square root of 92 squared is just 92. Now, which of these numbers is bigger? Obviously, we know 92 is bigger. So, since 92 is greater than 91, the square root of 92 is also going to be greater than the square root of 91. Okay? So if I think about it, if I'm looking at the square root of 36 and the square root of 25, the square root of 36 is going to be bigger because that is a bigger number. All right? So that one's kind of common sense. If I'm looking at two numbers and this one's bigger, when I take the square root, it's still going to be bigger. All right? I'm taking the square root of both of those. That is still going to be bigger. All right, one of the things I'm seeing on here too is this pi symbol keeps popping up. So that might be something else that's a struggle for some of you. So I'm going to try and show you some of that. What do we know about pi? Hopefully, from 7th grade. You remember that when we're talking about the number pi, we can say that it's about 3.14. Okay? Not exactly, but it's about 3.14 with a whole lot of other digits that just keep going and going and going. Okay? So what if I were to ask you to compare pi squared and 25. Okay, compare pi squared and 25. Well, we know pi is 3.14. Okay, so I know that pi is 3.14, approximately, and we're squaring it. So one option would be I could take this number and multiply it by itself and find out what that value is. Another option would be to find out what the square root of this number is. Okay, so I know the square root of 25 is 5. If I take the square root of pi squared, I just get pi. I know pi is 3.14. So now what we are doing is we can compare 3.14 and 5. That gets a lot easier to see, in my opinion. If I know 3.14 is less than 5, okay, that means pi is also less than 5, because these two are approximates. They're equal to each other. Okay. 5 squared gets us to 25. Pi squared would get us to a little bit over 9. Really close to 10. Okay. So 5 is bigger than 3.14, which means that when we square both of these, 25 is still going to be bigger than whatever number that is. So we could say that because pi is less than 5, so pi squared is going to be less than 25. Okay. All right, one more thing I'm going to show you on here. So, one of the things you might see on Study Island is this idea of these numbers out in front of the square root sign. All those are coefficients. They're multipliers. So, for example, if we had a number like 2 times the square root of 5. Well, if I come up here and I'm trying to find the square root of 5, square root of 5 is somewhere down here between these two numbers. Okay, so 5 is between 4 and 9 when we're looking at perfect squares. That means that the square root of 5 is between square root of, the square root of 4 is 2, and the square root of 9 is 3. So I know that that square root is in between these two numbers. So now what I need to do is I need to try and narrow that down a little bit further, like we did earlier. So I know 5 is closer to 4 than it is to 9. I'm going to spread this out a little bit. If I had the number 4 and the number 9, we have 5, 6, 7, 8. Excuse me. And then we'd have 9. 5, 6, 7, 8, 9. So, square root of 4 is 2. Square root of 9 is 3. I've got 1, 2, 3, 4, 5 intervals in between these two. I've got one spot, one number up here. So this is going to be really close to like 2.2. So let's try 2.2. 2.2 times 2.2. 2 times 2 is 4. 2 times 2 is 4. Got a 0. 2 times 2 is 4. 2 times 2 is 4. 484. It's pretty close to 5. Not quite there though. Okay, pretty close. So let's try something a little smaller. Let's try 2.1. One times 1 gives us 1. 1 times 2 is 2. 2 times 1. I'm sorry. I need to go a little bit bigger. I'm losing my mind, y'all. It's NTI and being home all day. I'm losing it. So it doesn't quite get us there. So that means we need to go a little bigger. Sorry about that. So let's try 2.3. So 3 times 3 gives us 9. 3 times 2 is 6. That's 0. 2 times 3 is 6. 2 times 2 gives us 4. And this one, when we add it up, 12. Notice it puts us a little bit over. So that tells me again, 5 is somewhere in between. So I can now say it's between 2.2 and 2.3. Okay, it's in between those two. So I'm going to erase this for a second because we don't know yet. All right. It's about a 1/16 off from this one, being at 5, and it's about 0.29 off on this one. So 0.16 off, 0.29 too much. This answer was a little bit closer. So what that tells me is that my answer is probably going to be somewhere around 2.23. Okay, it's going to be closer to 2.2 than it is 2.3. So let's try that. 2.23. 3 times 3 is 9. 3 times 2 is 6. 3 times 2 is 6. 2 times 3 is 6. 2 times 2 is 4. 2 times 2 is 4. Now we got 2 zeros. 2 times 3 is 6. 2 times 2 is 4. 2 times 2 is 4. Okay, let's add that up. We get 9, 12, carry the 1. I got 10, 17, carry the 1. 8, 9. I got 4.9729. That is a pretty good estimate if we're trying to get to 5. So I'm going to say that the square root of 5 is about 2.23. Now, I haven't answered my question yet because I have this multiplier out here. All that means is that we're taking the square root that we just found, so this right here, and we're going to double it. So what I'm going to do is we're just going to do 2.23 times 2. Okay, so that means this will be about 4.46. Okay. All right, guys, that's rational approximations. Hope that helps you out a little bit. I got one more video we're going to do. See you in a little bit.